in serial in parallel out shift register, data is input as before. That one bits data one by one is entered in the register, and the what configuration is changed as the data retrieved in parallel. So for 4-bit register we need 4 output. Parallel means all the data minded, all the data are retrieved in at a same clock pulse at the same time. In serial output register, all the data bits are retrieved for every clock pulse. You see here previously, here whenever 4th clock pulse we get one data, whenever 5th clock pulse we get another bit, whenever 6th clock pulse we get another bit, whenever 7th clock pulse we get another bit. So for every bits we need one clock pulse in serial out register. Okay, serial out means there is only single line and only one data can be retrieved at time, and for every bits we need one clock pulse. That is serial out. And for parallel out, for every data, every bits there is one single line. Okay, so in parallel register, for every output there is one single line. You see, this is the configuration here. Here it's so output is Q3 you get here. So for every output we draw another output line. For Q2 this is here, for Q0 this is here, for Q1 this is here, Q0. Okay. In previous only Q0 was there, but here in parallel output PO, for every output value we get only one extra pin for every output value. Okay, and others are same as it is. The for input value there is serial input, so only one input line, and the value of one flip-flop comes from the value of another. You see that this is connected, D2 is connected with Q3, D1 is connected with Q2, D0 is connected with Q1. Okay, for every value it is connected with previous output line, and we get output from every flip-flop. In serial output we get output from only the last flip-flop, you see, and here we get output from every flip-flop. This is the main difference. Okay, so as the data here also stored in serial way, that is one input line, and the value goes from D2 value comes from Q3, D1 value comes from Q2, D0 comes from Q1. So this is mechanism is same as explained earlier, this portion, the mechanism. Okay, the value of this goes this, value of this goes this, value of this goes this, and goes to the this, which we have described before. The mechanism is same as serial input in every flip-flop. So it stored delays for 4 bits data we need 4 clock pulse. Okay, but to retrieve data, as there is single input line for every output value. Okay, suppose we store here 1 0 1 1, 4 bits data stored, 4 clock pulse required to store the data. Okay, and whenever we get the value, here it is stored, so its value is there, so we get also the output Q3 value 1, Q2 0, Q1 1, Q1 1. So in this flip-flop we don't need any extra. Here you see, in 4th clock pulse all the data are stored in every flip-flop, and again we get the value from each flip-flop, and there is an individual output line, so we get one in flop from Q3 value, 0 Q2 value, 1 Q1 value, 1 Q0. Whenever data is stored here, we get the output. In D flip-flop, if the input is 1, output is 1. So as its input is 0, 1, so output is 1. Is input is 0, output is 0. Input is 1, output is 1. Input is 1, output is 1. Okay, so we get the value at the fourth clock pulse. We don't need any extra clock pulse to retrieve the data for parallel output flip-flop. So in serial input and parallel output flip-flop, only we need 4 clock pulse, the number of bits, the number of clock pulse to store and retrieve the data. So it takes less time than serial in parallel out flip-flop. Okay. This is the working of the flip-flop. Whenever we only need the definition of serial in, serial out flip-flop, you write only the first paragraph. Okay.